energy come from for what we're talking about? Well, atoms and molecules are always moving. So let's look at some molecules in here. So I have a mixture of different molecules in this sample, and all these molecules are moving around. Let's say this is a gas. So this one's moving that way, this one's moving that way. They're all kind of going off in random directions. So they clearly have motion. You can call this forward motion. Okay, they're moving from one place to another. They also move in other ways. For example, molecules can also vibrate in place, like in solids. But even gas molecules vibrate a little bit. They can also spin as they move through the air, kind of the way the baseball spins as it's thrown. And that's another kind of motion. All these things combined are the molecule's kinetic energy. And atoms and molecules are always moving, and they move quite a bit. You may not realize it, but the molecules in the air around you on a regular day are moving faster than a bullet shot from a rifle. So there's a lot of motion when we talk about atoms and molecules. Now you'll notice when I drew some of these motions in for these molecules, I gave some of them a lot of motion, and some of them only a little motion, and some in between. Each of these molecules has a different amount of kinetic energy. But the sample as a whole, if I consider all the molecules, their average kinetic energy gives me the temperature. And that's what it means to say temperature measures the average kinetic energy in a sample. So now we've talked about what temperature is, let's talk about how we can measure it. And we could answer that simply by saying with a thermometer. But it's worth noting that there are different kinds of thermometers based on how you're measuring the temperature. Now, weather reports here may give us degrees Fahrenheit, but we also have degrees Celsius as the metric unit. So the Celsius scale is a scale that measures temperature based on water. Well, how is it based on water? When the Celsius scale was set, they established that when water freezes, that temperature would be defined as 0 degrees Celsius. And when water boils, that temperature would be defined as 100 degrees Celsius. Most of the measurements we take will be in Celsius because we typically use Celsius thermometers and because it's a metric unit. So we're never going to use Fahrenheit in the lab. Celsius is the one to know. Let's talk about what these temperatures represent. We know that the 0 is based on the freezing temperature and the 100 is based on the boiling temperature, but they measure kinetic energy. So 0 should have less kinetic energy than 100. And we can go negative, right? We have negative temperatures. So we can keep getting lower and lower and lower. And lower temperatures should have lower and lower kinetic energies. Now we should hit a point, theoretically, where the kinetic energy is 0. And the temperature where kinetic energy is 0, we call absolute 0. Now this is a theoretical temperature because we haven't been able to get to absolute 0. But based on overwhelming experimental evidence, we basically figured out that absolute 0 should occur at negative 273.15 degrees Celsius. Now absolute 0 is so cool we actually made an entire scale based on it called the Kelvin scale. And expressing temperatures in Kelvin is going to be something very useful when we talk about gas laws. So the Kelvin scale is based on absolute 0. And basically, to convert to a Kelvin temperature, all you have to do is take the temperature in degrees Celsius and add 273 to get the Kelvin temperature. This is our conversion for converting Celsius temperature to Kelvin temperature.